Good day, class. So, our topic for today is all about the set of real numbers. So, we have the following. The first one is what we call the set of natural numbers. Okay, so this is also called or being known as counting numbers. Okay, so these are the numbers that naturally occur to us, such as the numbers 1, 2, 3, and so on. This is also called counting numbers because when we count, we start off with 1, okay, 2, 3, and so on. And this one is being denoted by n. Okay, so here are the following examples. The number 109 is included in the set of natural numbers. So when we count, we can go to 109. Therefore, it's a natural number. However, 0 is not included in the set of natural numbers. As I have said earlier, we do not start with 0 when counting, right? We start with 1. So 0 is not included in the set of natural numbers. Okay? So the second is what we call the set of whole numbers. Okay, this time it includes 0 and the natural numbers. It is being denoted by the capital W. Okay, so here are the following examples. Okay, so it includes 0. So from 0 and the natural numbers or the counting numbers, so we have number 28 and 130 are also set of whole numbers. Okay. However, the numbers -3, as you can see, it's negative. Okay. This is not a natural number, therefore it's not included in the set of whole numbers. Also, the fraction 3/8. Okay. We do not count with 3/8, right? Like 1, 2, 2 and 3/8. We do not do that. So it should be just the natural numbers and 0. Also, even if we have here a whole number or a natural number 1 and 4/5, still we have a fraction and it's not included. Same way with decimals, no? So decimals are not whole numbers. We do not count as 1, 2, 2.5, 2.6. We do not do that. We have 0, 1, 2, 3, and so on as the natural numbers. Again, for the whole numbers, it just includes the 0 and the natural numbers. Okay. So next is the third one is what we call the set of integers. Okay. So here it includes the natural numbers, 0, and the negatives of the natural numbers. Meaning to say, these are the negatives, 0, and the positive numbers. Okay. It's denoted by Z. Also, the set of positive integers can be denoted as z positive or z plus, while that of negative integers, it's by z negative or z minus. Okay, so here are our examples. We have -2, 0, and 4. As you can see, we have here the negative natural number, 0, and the natural number or a positive number. Therefore, it's integers. On the other hand, we have -1/3, 6/11, 6 and 2/5, and 2.4. They are not included in the set of integers. Okay. So again, for set of integers, it's only the negative, 0, and the positive natural numbers. Okay. So the fourth one is what we call the set of rational numbers. So here, it includes the numbers or includes numbers that can be written in the form a over b, where a and b are integers and b is not equal to 0. Okay, so here, if we try to look at this one, if we have here 0, okay, it will be undefined, right? So any number over 0 is undefined. So b should never be equal to 0. Okay, and the set of rational numbers class is being denoted by q or the capital letter q. That's the symbol for that. We have here the following examples. We have the numbers -3/11, 9/16, 13, 0.3, and 1.25. These are set of rational numbers. So basically, class, rational numbers are just fractions. Okay, so as you can see here, if we can write these as fractions, so the first two examples are already in fraction form, therefore they are rational. Here, the third one, 13, we all know that for a whole number, there's always a denominator of 1. Therefore, we can still write that as a rational number. Same way with these decimals, okay? So, we tackled or discussed already how to write this or convert this to fraction. Therefore, they are rational numbers. Again, for the rational, if you can convert it or if it can be written as a fraction, therefore it's rational number. Okay? However, here, pi is not included in the set of rational numbers. So pi class, it's 3.14, etc. No? So the decimal there is unlimited or infinite. Therefore, we cannot write that in a form of a fraction. Therefore, it's not included in the set of rational numbers. Okay? So we have the fifth is what we call the opposite of rational numbers, is what we call the set of irrational numbers. Okay, so here it includes numbers that cannot be expressed as a ratio of integers, meaning to say it's the opposite of the rational. You cannot express it in a form of a fraction, and this is being denoted as q prime. Remember, in sets, the prime is not or not included, no? So it's not rational or irrational. Okay. So here are the following examples. Okay. Square root of 3. When we simplify that, okay, it's infinite also, the decimal. And the pi, okay, and the Euler's number. Okay, so here, Euler's number is also irrational since the decimal or the simplification of this one is unlimited. The decimal is unlimited. Therefore, they are irrational numbers. Okay. So here, these are not irrational numbers. We have the following examples: 1/2, 0.9, and 0. As you can see, 1/2 is a rational number. Same way with the 0.9, and 0 is a whole number, right? Therefore, they are not irrational. Okay, so these are only the irrational. Again, irrational are not or not rational. Okay, we cannot express that in a form of a fraction. Okay, so here, since we are discussing or talking about a real number, so what is a real number or what are real numbers? So it includes rational and irrational numbers. It's denoted by capital R or the symbol. Okay. So the examples of real numbers are the following, okay? Meaning to say it's a combination or it can be either rational or irrational numbers. They are real numbers, okay? So, however, the number square root of -1 is not a real number because the square root of -1 is an imaginary number. We will not talk so much on this since we are only dealing with the set of real numbers. So basically, this is the head, okay, and the subsets are the rational and irrational. So here, the set of real numbers, okay, again, it includes the rational and irrational, and we have here the diagram, okay. So basically, this entire circle is representing the set of real numbers. It can be rational or irrational, and the other three that we discussed are subsets of rational. They are under rational numbers. Okay, so to summarize class, the set of real numbers are this one, okay? So we have the real numbers, okay? And below that, okay, or under that, we have the rational numbers and the irrational numbers, okay? So these irrational numbers cannot be formed in fraction, okay. So here the rational numbers, below that we have integers, whole numbers, and the natural or counting numbers, okay. So for your assignment, just identify the subsets or the sets of real numbers for each item and name all that applies. So we have here 5 items. Please name them. One fifth is that rational, whole, okay, natural, irrational, and others. Okay, so thank you so much for listening.